Hello, hope everyone is doing all right. My name is Filipe, and I am one of the authors of this paper titled Page Inspector, Web Page Analyzer. Let's start by a brief introduction about web and web accessibility. Web accessibility refers to apps, websites, and digital tools designed to be accessible by all users, including those with disabilities. The web is a source of public information, education, government, health, and many others, and every person, regardless of ability, has the right to be able to access it. Imagine missing out on thousands of new customers because your competitor has an easier-to-use WCAG-compliant website. The design and development of this tool consists of an open-source web platform which allows anyone to analyze any web page. Have you checked to see if your institution is creating websites and apps that follow the Web Accessibility Content Guidelines, or WCAG for short? If not, millions of people won't be able to use them. Web accessibility isn't just for people with disabilities. It is an initiative to improve the quality of the internet for every user. In 1999, the W3C Web Accessibility Initiative published the first version of its WCAG, which has become an international benchmark. In September 2018, the European Union adopted WCAG 2.1 as a standard for websites and electronic documents. WCAG recommendations help website developers and designers better meet all users' needs, including those with disabilities and older users. These tools are not just for website developers and designers, but also for creators and developers of web accessibility evaluation tools. It can also be used by anyone who needs a reference standard for checking the accessibility of a specific web content. The Web Content Accessibility Guidelines are a series of guidelines for improving web accessibility. Created by the World Wide Web Consortium in cooperation with individuals and organizations worldwide, WCAG are the required guidelines for making your website available for all users. The first version was published in May 1999. WCAG 2.0 was published in December 2008, and the WCAG 2.1 in June 2018. The first public draft of WCAG 2.2 was published in February 2020. WCAG 1.0 has 14 guidelines or general principles of accessible design and 65 checkpoints. The checkpoints are specific enough so that anyone reviewing a page or website may verify that the checkpoint has been satisfied or not. WCAG 2.0 has 12 guidelines organized under 4 principles: perceivable, operable, understandable, and robust. For each procedure, there are testable success criteria, which are 3 levels of compliance: A, AA, and AAA. WCAG 2.1 extends WCAG 2.0 by adding 17 new success criteria, 1 guideline, and a couple of additions to the compliance section. This approach means that websites that comply with WCAG 2.1 also comply with WCAG 2.0. WCAG 2.2 updates focus on mobile accessibility. Due to the increase in mobile users globally, this update was essential to ensure that websites were created to optimize mobile usability. WCAG 2.2 is a backwards compatible, extending WCAG 2.0 and 2.1. Therefore, if a website conforms with WCAG 2.2, it will automatically conform with 2.0 and 2.1. The main objective behind this tool, called Page Inspector, is to allow anyone to analyze their web pages for free. This platform provides a set of detailed reports to help anyone make their websites more accessible and more appealing to search engines. The platform provides a set of reports like spelling, accessibility, cookies, technologies, images, subdomains, Google Lighthouse, and hyperlinks. In addition to these reports, it allows the user to view their website in real time, in mobile or desktop versions, as well as the source code. All reports are also available through a dedicated API, so you can integrate them with your platforms. Requirements gathering is closely linked to the quality of the software. The requirements can be divided into 2 categories: functional and non-functional requirements. Functional requirements are related to the services that the system should offer. Examples are: the Page Inspector system should allow viewing of the intended website in real time. It should also allow selecting the view modes, such as desktop, mobile, and source code. It should also allow for spelling analysis and other types of analysis, and allow viewing of the spelling errors in the page context, just like all of the other errors for all types of reports. Non-functional requirements are related to specific system characteristics or restrictions. For example, the Page Inspector must provide access to reports through an API, must give the possibility to use cache when generating a report, and must use SSL certificate to ensure client-server security. The activity diagram presented refers to the base functioning of the platform. Activity diagrams allows you to monitor the flow of actions that are a part of a larger activity. They are commonly used to specify the cases and class operations. It is very important that the diagram contains the minimum information necessary to communicate the message. As a web page analysis platform, the following diagram represents the process to generate any report. The process starts by identifying the necessary information. For example, for the spelling report, the necessary information will be the URL, the language, and the content. Then send that information to the server through a POST request. The requested report is checked to see if it is already cached. If it is, then a JSON response is returned. Otherwise, the dedicated script for each type of report is executed. Then the JSON is saved for future cache. And finally, the JSON is returned to the client. Finally, in the client, the JSON information is added to the tables. The platform's homepage allows the user to view the desktop version of the page to be analyzed. The page can also be loaded by entering the URL in the top bar, as well as selecting the page language and the WCAG accessibility level. In the sidebar, there are different views: desktop, mobile, and code. In the desktop version, the page is loaded and displayed just as it would be on the desktop. The same goes for the mobile version. The view code allows the user to see the source code of the page. By default, the page is loaded in the desktop version. In the sidebar, the user can access the various reports. If the user wants to access the desired page directly, he can add the URL argument to the page URL. Users can also add the language argument to indicate the language of the page to be analyzed. The spelling report aims to make a spelling analysis of the page, thus allowing the user to view the spelling errors present on the page in order to correct them. The analysis is done through an open source tool called Language Tool developed in Java. This report, like all of the others, is available in the form of an API, receiving as arguments the URL, content, and language of the page. The API returns a JSON response. If the user has not specified the language, then a language detection is performed. If this argument cannot be found, a prediction is then made by Language Tool. Finally, if both fail, the British language is used by default. The user's dictionary is managed through a cookie stored in the user's browser. In this way, it allows the user a more fluid and continuous experience. At the top, we have an overview of the report, and on the table several useful information, like replacement words, then the number of occurrence of the error. Here we can see in the context of the page where exactly the error is found. This accessibility report intends to present to the user the various accessibility errors of the page, just like warnings and notices. This analysis allows you to verify whether the page complies with the Web Content Accessibility Guidelines. This analysis is done through a library developed in Node.js called HTML Code Sniffer. This tool takes as arguments the URL of the page and the accessibility level, AA or AAA. The API returns a JSON response, and by default, the accessibility level is WCAG AA. On the table, we can see exactly what guideline and the message associated with the error. Once more, here we have the errors on the context of the page and on the context of the source code. The cookies report seeks to show the user, as the name implies, which cookies are present on the page. This analysis is done by a library developed by Google in Node.js called Puppeteer. This library allows to control in Chrome or Chromium through the DevTools protocol. The API takes the URL of the page as an argument and returns a JSON response. On the table, we have several pieces of information, like the domain, the expiry date for each cookie. Here we have the technologies report that aims to present the technologies used by the page. This analysis is done by a library developed in Node.js called Analyser. The API takes the URL of the page as an argument and returns a JSON response. On the table, we can see the names, website, and categories for its technology to better understand how a page was built. Here we have the images report with the objective to present the images present on the page to the user. All of the analysis is done by a library developed in Python called Pillow. This library allows you to identify and analyze images present on a given page. The API takes the URL of the page as an argument and returns a JSON response. The information shown in the table is the image itself, the file name, the status code to help with broken images, It also shows the file size. This helps with optimizing the loading speeds. Also shows the alternative text, also related with web accessibility in case of screen reader. This is the subdomains report that aims to present the user with the subdomains related to the domain of the page. The analysis is done by a tool developed for Linux, Windows, and macOS. This tool allows you to analyze the certificate transparency log (CRT) of a domain. The API takes the URL of the page as an argument and returns a JSON response. On the table, you can see the name and the entry timestamp for each subdomain. Here we have the Google Lighthouse report. This one aims to present to the user the report made by Google Lighthouse of the Analyze page. The analysis is done by a library developed by Google on Node.js called Lighthouse. It performs a number of audits like performance, accessibility, progressive web applications, and SEO audits. The Lighthouse tool receives a URL and it performs a series of audits on the page and then generates a report on the page's performance. The API takes as an argument the URL and a device to be used as a test, desktop or mobile, and then returns a JSON response. This is the hyperlinks report. This report intends to present the hyperlinks present on the Analyze page to the user. The analysis is done by a library developed in Node.js called URL Status Code. This library allows you to identify and analyze the hyperlinks present on a given page. The API takes the URL of the page as an argument and then returns a JSON response. On the table, you can see we have all the URLs, the status code, and the origin, internal or external, of every given URL. In the case of a broken link, we can see exactly on the page the link is located so we can fix it. Another important piece of the development was security. The user does not need to have authentication or authorization to enjoy all of the features of the platform. However, there are several other areas of computer security that have been taken into account throughout the development of this platform. To access the hosting service, two-factor authentication is required, that is, a username-password combination, as well as a 6-digit verification code sent to the mobile phone or to a mobile application. Server access via SSH Secure Shell Protocol is also assured. Each user has their individual account and the username-password combination is required, as well as a private key. The version of Linux Ubuntu Server is the latest long-term release, and to combat computer attacks, updates are being made daily. To avoid data loss in the event of a catastrophic failure, a backup policy was adopted. This policy is known as 3-2-1, 3 backups in 2 types of storage, with at least one of them being off-site. Therefore, every night 3 full copies of the server are made, a local copy, another on an external device, and another on a cloud service. We also use the password manager to assure the security of passwords, private keys, and other types of important information. To conclude, here are some key takeaways. Having an accessible website allows you to connect with a broader customer base. Since the beginning of the pandemic, more and more people have been shopping online. Coupled with the fact that 1 in 5 people in the UK are living with a disability, the digital landscape will be more challenging than ever before. It also allows you to increase e-commerce sales. Creating web content that is accessible for everyone will maximize its ever-growing customer base and maximize customer loyalty. It helps with future-proofing your institution. More clients will start demanding websites that are web accessible as they realize how it benefits their website and brand image. Many clients are already asking agencies to make accessibility part of their offering, so it would be wise to prepare for an imminent surge in demand. It also allows you to create better products. This isn't just about creating an inclusive product. Following accessibility best practices improves overall SEO, bounce rate, and digital quality. And at last, it helps avoid lawsuits for your clients. Covered in the UK by the Equality Act of 2010, web accessibility isn't just a nice thing to have. It is a legal requirement. This means that having a website that is not WCAG compliant puts your client at risk of hefty fines and legal penalties. Thank you.